Right, greetings to you all viewers. Greetings to you all viewers. Today we are back and we want to talk about combined science. We want to talk about combined science. We want to talk about combined science. And I'm going to do only 3 videos to complete chemistry section. I'm going to do only 3 videos to complete chemistry section. So today we are on matter. But please guys, share these videos to your friends, to your loved ones. And after watching, don't forget to subscribe. Don't forget also to like. And we really appreciate your comments. We really appreciate your comments. And I want to thank Baba Metro. Who is supporting us financially. Baba Metro is supporting us financially. We appreciate your love, say. So today I want to talk about matter. Alright. So for me to talk about matter, let me explain this one. Okay, let me say matter is anything that has mass and volume. Matter is anything that has mass and volume, or anything that can occupy space. That is matter. Matter is anything that has mass and volume, or anything that occupy space. That's what we call matter. Alright, matter can be found in 3 important states. Matter can be found in how many? 3 important states. What are those states? Alright, allow me to draw something here. Alright, matter can be found on 3 states. Number 1 is solid state. Alright, from solid state we have also liquid state and gaseous state. Alright, these are 3 states of matter, and you need to be careful on the changes that take place from solid to liquid and also to gas, and to know what actually causes the change of state from solid state to liquid state and to gaseous state. What causes that? Right, the solid state particles are tightly packed to each other. So I'm going to present to you this one. Particles are tightly packed together. As you can see, there is no space. Particles cannot move freely. And in liquid state, particles, they are free to move. They are free to move like this. Then in gaseous, particles also, they are free to move like this. They are free to move. So I want to explain to you what causes the change from solid to liquid and to gas. What causes that? Right. What causes the change of state from solid state to liquid state is the application of heat energy. So when we apply heat energy to a solid material, to the particles that are tightly packed to each other, what happens? Those particles will loosen together, and they form what you call what? Liquid. For example, we have a freeze here. Right, we have a freeze. It's like a freezer. Right, when we apply heat to this one, the freeze it will melt and become what? A liquid freeze it, which means the liquid can move from solid state into liquid state. But what causes that is the application of heat energy. Right? For example, we have ice. Ice is here. If we heat ices, they melt and they form what? Liquid. But if we continue applying heat energy, that liquid can evaporate, forming what? Gas. That is the transformation that takes place. I am explaining matter. What is matter and how matter is formed. Right. For us to understand the main subject of today, which is the atom, we must first understand what we call matter. Okay, let's move on and talk about what we call an atom. But before that, let me talk. The change from solid to liquid is called melting. And the change from liquid to gas is called evaporation. The change from gas to liquid, this is caused by removal of heat energy. This is called condensation. Then the change from liquid to solid, this is called freezing. And the change from solid straight to gas is called sublimation. It's called sublimation. These are the changes in the states of what? In the states of matter. Right, please share this video to your friends so that they will also benefit and they also pass. Right, let's go to atom. I want to explain atom, but for us to understand what is an atom, we must have enough information about matter. Right, let's continue. Now, let's talk about matter. Right, there is a man by the name Dalton. Dalton suggested that the existence of atoms in all matter. He said there is existence of atoms in all matter. Matter, what is matter? Matter is anything that has mass and volume, anything that can occupy space. Then Dalton said there is an existence of atoms in all matter, which means in anything that has mass and volume, there is an atom. In anything that can occupy space, there is an atom. So, Mr. Dalton, what is an atom? What is an atom? So he went on to say, thus, matter is made up of atoms. I don't know if you are following. Please, just listen to me. We are saying, Dalton said, there is an existence of atoms in matter. And matter is anything that has mass and volume, anything that can occupy space. Which means in anything that has mass and volume, in anything that can occupy space, there is an atom. And he concluded by saying, this means matter is made up of atoms. Which means, in other words, he is saying anything that has mass and volume is made up of atoms. Anything that occupies space is made up of an atom. My question is, what is an atom? Then this book is saying an atom is the smallest unit of an element. Is that a correct definition? It seems as if a matter is an element. So let me try to explain in line with what we discussed about matter. I think we can say atom is the smallest particle of matter. Is the smallest particle of matter. There is anything that is mass and volume, which is called matter. But in anything that is mass and volume, the smallest particle of that thing that is mass and volume is called an atom, because an atom is the smallest particle of matter that can take part in any chemical reaction. Wow, that can take part in any chemical reaction. That is an atom. And he said, if an atom is the smallest, you see, if an atom is the smallest particle, it means an atom cannot be created. and cannot be destroyed. Right? And we cannot see, using a naked eye, we cannot see an atom. Right? Let us move on and look at the structure of what you call an atom. The structure of what you call an atom. See now, this is the structure of an atom. This is the structure of an atom. 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 All right. Atom is made up of 3 important subatomic particles. All right. Atom is made up of 3 important subatomic particles, and those subatomic particles, we are referring to electrons, we are referring to protons, we are referring to neutrons. These are 3 subatomic particles. What are subatomic particles? These are particles that make up atom. These are particles that make up atom. Okay, you see this hierarchy? An atom is made up of 3 important subatomic particles, that is electron, proton, and neutron. And matter is made up of atom. Hey, amene ngana mchine nzwisa amene kuti kubatika here baba. Wow. Okay, so this is the structure of an atom. All right, there is electrons, as you can see. There are electrons here. The electrons. These are electrons. All right. What is very, very important when we're talking about electrons? Electrons, they are found on shells. These are electron shells. These lines, they are called what? Electron shells. This is the structure of an atom. Those lines, they are called electron shells, or they are called orbits or orbitals, or they are called energy shells. So we have 3 names to call this. They are called electron shells, energy shells, or orbitals. Right, so all electrons, they are found on shells, they are found on orbitals, they are found on electron what? Shells. And what is special about electrons? All electrons, they are negatively charged, which means they have a negative what? Charge. All electrons, they are negatively charged, which means they have a negative charge. That's why there is a negative here. That's why there is a negative here. And this center, this one, is called the nucleus. This is called the what? The nucleus. Right, in the nucleus, we found what? We find protons and neutrons, which means protons and neutrons, they are found on the what? On the nucleus. They are found on the nucleus. What is so special about protons? Protons, they are positively charged, and they are found in the nucleus of an atom. Protons, they are positively charged, and they are found on the nucleus of an atom. And neutrons, they are zero charge. They have zero charge. They have what? Zero charge. And they are found on the what? On the nucleus again. Which means protons and neutrons, they are both found on the what? On the nucleus. So there is a funny question which come and say, why protons and neutrons, they are called nucleons? If you check my videos, you can see those questions where I was answering those questions. Why protons and neutrons, they are called nucleons? The reason is very simple, because they are both found on the nucleus. Because they are both found on the what? On the nucleus. That is the answer. This is the structure of an atom. Right, let's move on. We want to move with chemistry. Right, electrons, we explained all these, we explained, right? All right, name the subatomic particles and their relative charge, masses, we explained this. We have done this. Tataura isusu tikati maparticle proton inowanikwa the nucleus, neutron, nucleus, electron, atomic shells. Then there is a proton, they have positive charge which is +1. Then neutron tikati ine 0 charge. Ndobva tati electron ine negative what? Charge. Then symbol is P and stuff like that. The mass is 1 and stuff like that. Tatotsanangura kudhara izvi. Right, let us move on and talk about what we call nuclide notation. What is nuclide notation? Oh, wow. Nuclide notation. Nuclide notation. Nuclide notation, we are presenting an element symbol, nucleon number, and proton number. That's what you call nuclide notation. So, here, I want you to listen to me. All right, this is a good example of a nuclide notation. We're going to put nucleon number here, and we're going to put proton number here, and we're going to put electron symbol here. Right, for example, we have carbon. You go into the periodic table. Carbon have a mass number of 12, and has a proton number of 6. So nucleon number is the mass number. That's why I put mass number here. Then the element symbol for carbon is C. This is what? Nuclide notation. This is what you call nuclide notation. So there are many questions being asked when it comes to nuclide notation. They ask you number of neutrons. We have mass number. We have proton number. How do we find now the number of neutrons? The number of neutrons, we are going to say mass number minus proton number. Then we get number of neutrons. Then we get number of what? Of neutrons. We are going to talk about what you call mass number. What is mass number? What is proton number? And stuff like that. We are going to talk about that. Proton number, we are referring to the number of protons. We are referring to the number of protons. And number of protons, sometimes they are called the atomic number. The atomic number is proton number. We are going to explain that. So let's move on and talk about what you call mass or relative mass. Mass number or relative what? Mass. Mass number or relative mass. All right, what is it? Right, relative mass or mass number is the number of protons and neutrons in a nucleus. Simple. If you are given any atom, if you are given an atom, given the number of protons, given the number of neutrons, just add the number of protons plus the number of neutrons, then you get what you call what? Mass number. So mass number, this is the sum of proton and neutron number in a nucleus. Simple. This is the total number of protons and neutrons in a nucleus. That's what you call mass number. And we move on, we want to talk about what you call the proton number or atomic number. Proton number, this is the number of protons in a nucleus. Proton number inogona kutonzi atomic number. Vachibvira kuti this is the number of protons. Here, see now. This is the number of protons in the nucleus of what? Of an atom. Okay. There is this point which is very, very important. The next point here is the atom has no charge. The atom has no charge. Electrically neutral. So electrical neutral, it means no charge. Electrically neutral, it means no charge. So in other words, they are saying an atom is electrically neutral, or an atom has no charge. Why? Because the number of electrons is equal to the number of protons. Because the number of electrons is equal to the number of protons. Right. So there is a question which comes and say, why an atom is said to be electrically neutral? The answer is very simple, because the number of protons is balanced or equal to the number of what? Number of electrons. What are we saying? We are saying neutron number is minus. All right, let me start by proton number. Proton number is +1. Right, then neutron number is -1. So proton number it's +1, then electron number, this is proton number +1 from the table that we saw above. Proton number is +1 and electron number is -1. So what do you get? 1 minus 1, we get 0. We get 0. That's why we are saying an atom is neutral. An atom is neutral. Because if we add number of protons and number of electrons, they will give you 0. But don't say, because if you add, no, the answer is the number of electrons is equal to the number of what? Number of protons. Let us move on and talk about what you call isotopes. Isotopes. Right, isotopes are atoms of the same element. All right. Are atoms of what? Same type. Let me say same type, not same element. Same type with the same atomic or proton number, but different atomic mass, but different mass number. Hey, in other words, let me say, in other words, an isotope is the same type of an atom with the same number of protons, but different neutron and mass number. Same number of protons, but different neutron and mass number. For example, we have carbon. I'm very sorry, I'm going to draw here. We have carbon. For example, we have what you call carbon 12. Then the proton number is what? Well, I'm going to draw in Euclid notation. Then the proton number or atomic number is 6 from the periodic table. Then we have what you call carbon 13. The atomic number remains 6. Then we have what you call carbon 14. And the atomic number again is 6. So this is a good example of what you call an isotope. We are saying an isotope is the same type of an atom. There is carbon, carbon, carbon. Same type of an atom. Same number of proton, 6, 6, 6. But different mass number, 12, 13, 14. And also different in neutron number. How do you find neutron number? We said if you want to find neutron number given Euclid notation, you're going to say mass number minus proton number, then you get 6. You get 6 here. Right? Mass number minus proton number will get 7. Mass number minus proton number will get 8. So you see now, Kuti, an isotope is the same type of atom. We have carbon, carbon, carbon. With the same number of protons, 6, 6, 6. But different mass number, 12, 13, 14. And also different neutron number, which is 6, 7. This one. That is an isotope. I think you get it. So we have different types of isotopes. We have carbon, the isotopes of carbon, which is given here. And we also have the isotopes of chlorine. There is chlorine 35 and there is chlorine 37. As you can see, the difference is on the mass number and electron number. So you see now, the difference is what? On the mass number and what? Neutron number. Right? Mass number is 35, mass number is 37. The difference of an isotope. And also difference in the neutron number. If you subtract this one minus this one, we're going to get something, and this one and this one, we're going to get something which is different from this one. So this is another example of an isotope, and we have isotope of oxygen, which is oxygen 16 and oxygen 18. We have same proton number here and the same atom, which is oxygen, but the difference is on the mass number. We have mass number 16 and we have mass number 18. That is an isotope. Okay, let us move on. Isotopes of carbon and stuff like that. Right, mass number. How do you calculate mass number? We said mass number is equal to proton number plus neutron what number. Proton number plus neutron number, we get mass number. This M represents mass number, and this one P, it represents proton number, N represents neutron number. So if you are asked to find proton number given the mass number and neutron number. You're going to say mass number minus neutron number. If you are given mass number and proton number, you're going to say mass number minus proton number, so that you can get what? Neutron number. Right, that's how we calculate. Let us move on. This one is already explained. Yes, the periodic table. Okay, let's move on. Let's go to what you call electronic configuration. Electronic configuration. Electronic configuration. What is electronic configuration? In other words, okay, let me give another definition. Electronic configuration, this is the arrangement of electrons in shells. Simple. The arrangements of electron in shells. The arrangement of electron in shells. The arrangement of electron in shells is called electronic configuration. How do you draw the electronic configuration? You draw the electronic configuration after checking this one. You must be careful on the number of electrons each shell must hold. The first shell must hold a maximum electrons of 2. The second shell must hold the maximum electrons of 8. The third one a maximum of 8. The fourth one a maximum of 18. And the fifth one a maximum of 18 again. So we are going to demonstrate how to draw electronic what? Configuration. So let's go to the periodic table. We want to go to the periodic table. We want to choose one so that we can draw electronic configuration. Right. For example, we want to draw electronic configuration for magnesium. Right. Let us use magnesium as our example. We're going to use magnesium as our example. All right, magnesium is what? 12 electrons. Is 12 electrons. Is 12 what? Electrons. This is the number of electrons or the number of atoms. This one is 12 electrons. So we want to draw electronic configuration for what? For magnesium. And this one is the mass number. This one is the mass number. 24.305. This is the mass number for magnesium. So we want to draw the electronic configuration for magnesium. Okay, let's see how to draw it. Okay, let's go. Let me find a space here. Right here. Right, we have Mg. We have Mg. The symbol for magnesium, right? And magnesium, how many electrons does magnesium have? Have 12. So the first shell, we must first write what you call electronic configuration number. Right? How do you write that? I'm going to interpret here. Right? We said the first shell must hold a maximum of 2. So we are going to remove 2 electrons here, then we put 2, then put comma. Right? 12 minus 2, we left with what? With 10. Then the second shell said must hold a maximum of 8, then we remove 8 from 10, then we have 8 here. Right? 10 minus 8, we left with what? With the 2. Then the last shell must have 2. Though the last shell hold a maximum of 8, but we have 2. There is no option. We are going to just put 2 electrons in the outermost what? Shell. Because no asara. Right. Let me draw the electronic what? Configuration. I will draw. Right. First of all, write the element symbol in the middle. Mg. Right. I'm going to write. Let me wrap this one. Then I will start again. Then we have 2. Then we have 8. Then we have 2. This is the electronic configuration number. Right. Then we want to draw the electronic configuration diagram. Right. We put Mg here. Mg. Then we draw first shell. Alright, this is the first shell. We put 2 electrons only here. These 2, 1, 2. Right, we are going to draw the second shell. So when you are indicating electrons, you can indicate by putting a dot or a cross. Right, then the second shell. The second shell is what? 8 electrons. 8 electrons. I'm going to put 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Right. This one. We are done with this one. We are done also with this one. Right. The last shell, which must have a maximum of 8, but we have 2. We are going to put those 2. One, 2, like this. This is the electronic configuration diagram for magnesium. Now the electrons are arranged in order. The first shell is this one, F2. The second one, 8. The third one has 2. Then in the nucleus here, we put the element symbol. That's how we draw what you call electronic configuration. Okay, let's move on. Wow. Let's keep on moving, guys. Let's keep on moving. Right, this one is being interpreted here. Okay. This one, as you can see, these are electronic configuration diagrams being drawn. This is electronic configuration for hydrogen with 1 electron. Yes. This one is the electronic configuration for carbon. This one is the electronic configuration for argon. Okay. The significance of electron configuration, you can read on your own. The importance. These are the importance or the significance. The importance you can read on your own. Alright, let's go to what you call chemical bonding. Hey, yeah, you must listen like never before. You must listen. You must carefully listen to this. You must carefully listen to this. Alright, chemical bonding. Alright, what is chemical bonding? Is the combination of elements to form compound. What you call chemical bonding is just the combination of elements to form what? Compound. So what is a compound? A compound is a chemical composition of 2 or more elements. Just a chemical composition of 2 or more elements chemically joined together. Chemically joined together. Chemically joined together. For example, carbon dioxide is a compound of 2 gases, that is carbon and oxygen. But they are chemically what? Joined together. That is a compound. For example, water is a compound of hydrogen and what? And oxygen. So that is a compound. Or in other words, we can define compound as a new substance formed when 2 or more elements chemically joined together. Chemically joined together. So in this topic, let me also explain what you call an element, what you call a compound, what you call a mixed. Because there are different headings here. Of course, we have the heading which says chemical bonding, but we must explain what you call elements. Right, very, very important. We must also understand what we call compound. Right. Yes, chemical bonding is the combination of elements. But what is an element? It's the combination of elements to form compounds. That is chemical bonding. So compound, we said, compound is a chemical composition of 2 or more elements chemically joined together. Or is a new substance formed when two or more elements are chemically joined together. Tikabatanza zvinhu two zvikatiformera something that is a compound chatafoma chacho, but zviri kufomesa ndozvatiri kuti ma-elements. So what is an element? An element is a substance made up of one kind of an atom. Made up of one kind of an atom. Made up of one kind of atom. So it's a substance made up of one kind of an atom. That is an element. What is a mixture? A mixture is a substance consists of two or more elements, but not chemically joined together. But not chemically joined what? Together. That is a mixture. So I explained element, compound, and what? Mixture. Okay? Let's move on. We want to talk about types of bonding. We have two important types of bonding. We have two important types of bonding. We have what we call ionic bonding or electrovalent bonding. Ionic bonding or electrovalent bonding. Right? I am going to give you the definition so that if the question comes and say define ionic bonding, you'll be able to answer that question. So what is ionic bonding? Okay, ionic bonding is a type of bonding. Okay, let me explain what is to bond. To bond means to join. To bond means to join chemically. Is to join chemical. Is to join chemical. Is to join chemical. So what is ionic bonding now? Ionic bonding is the type of bonding where atoms or where an atom donate or receive electrons. Wow. I don't know if you are getting me. Wow. Right? A chemical bonding, we said this is the composition of elements to form a what? A compound. Composition of an element to form a compound, or the combination of elements to form what? A compound. Now, we are talking about another type of chemical bonding. Number one, we said ionic bonding. Right? What is ionic bonding? Ionic bonding is a type of bonding when an atom either receives or is donating electrons. Either an atom is receiving or is donating electrons. That is ionic what? Bonding. For example, if an atom donates, so apana situation yekuti atom inodonate aigwa receiver. No, one atom is donating and the other one is receiving. That type of bonding is called ionic or electrovalent what? Bonding. That is ionic bonding. Right. We must talk about some of the things here. Right. All metals, all metals, not some, all metals, they are called cations. All metals, they are called cations, and when they donate electrons, my God, and when they donate electrons, they become positively charged. When they donate electrons, they become positively what? Charged. These are metals. And non-metals, they are called anions or anions. They are called anions. When they receive electrons, they become negatively charged. Wow. Hey. Mero zvirubatika here. Mero zvirubatika here. Ndutsanangura nezvimwe zviri manonsi boss anenge asinganyasonzwisika, but I want you to listen to me. Tiri kuti isusu ma-metals akadonate ma-electrons, they become positively charged, and because of that they are called cations. Right? And non-metals, when they receive electrons, they become negatively charged, and because of that they are called anions. Wow. Okay. I don't know if I'm making sense here. Right? There is what you call valence. and what you call valence electron. Right, here we have the definition. Yes, we have the definition here. Right, a valence is an atom. Sorry, valence of an atom is the number of electrons which an atom should gain or lose to attain gas configuration. First of all, I think before I proceed, first of all, let me explain what is ionic bonding. I want to demonstrate, but there is one thing that you must know. Ionic bonding occurs only between metals and non-metals. Occurs between metals and non-metals. Ionic bonding, an atom is either donating or receiving electrons. Ionic bonding also occurs between metal and non-metals only. Haiti non-metals yet, Haiti metals yet, but between metal and non-metal. Let us go and demonstrate how ionic bonding takes place. Okay? I hope you are following. Right. See now. Right. We have Na. We have Na. What is Na? Okay, let's go to periodic table. I want you to see, or you can know. Periodic table. You can go and check on your periodic table. Right. Na, it represents sodium. I think there's an expansion above here. Yes. There is sodium here. We want to ionically bond sodium and chlorine. Ionically bond sodium and chlorine. We want to bond ionically sodium and chlorine. And sodium here is a metal. And chlorine is a non-metal. So you see now, chlorine is a non-metal, sodium is a metal. And if they react, they give us what? Sodium chloride. Right? Wazwona here kuti I metal ne non-metal kana zvikareacta inotonzi ionic bonding. This is ionic bonding. So we want to demonstrate how ionic bonding takes place. Right. First of all, draw electron configuration for sodium. Then you draw electron configuration for chlorine. You see? Right. We have this one. Right. Chiona manje. Apa kana zvakadai so. Unofana kutarisa kunonzi ku outermost shell. What is an outermost shell? Outermost shell ndo the last shell. Saka ngaticheke ku outermost shell redu. Toda kuona kuti isusu outermost shell rine ma electrons akawanda nderipi. Because pane imwe term yandoda describe baba. Nderipi rine ma electrons akawanda. Right, toda kuona ku chlorine. Kulunoti 1 2 3 4 5 1 2 3 4 5 6 7. Chlorine ku outermost shell ine 7 electrons. Okay, let's go to metal, sodium ine 1. Right. Ndoda tuone chinji. Right, pane term rinonzi electronegativity. There is a term called what? Electronegativity. Right, what is electronegativity? Electronegativity is the tendency of an atom. The tendency or the ability of an atom to attract electrons from another atom. That is electronegativity. So electronegativity is the tendency or the ability of an atom to attract electrons from another one atom. And an atom with a higher electronegativity is an atom with more number of electrons in the outermost shell. Wow. Saka ona manje, atom inenge ine high electronegativity ndo ino attract ma electrons kune ine lower electronegativity. You see now? Right, check. Saka uchaona kuti chaita kuti nitrogen idonate chi. It's because nitrogen in a lower electronegativity. And chaita kuti chlorine idonate chi. Inyaya kuti chlorine in a higher electronegativity. Saka in ability to attract my electrons to another atom's outermost what? Outermost shell. Right. Saka chicha akuitika. Tiri kuda kuti isusu ti achieve inonzi stability or noble gas configuration. Right. Saka nitrogen, sodium, kuti ive stable, kana kuti ive nema electrons arifu, kana kuti ma electron shells akakwana kana kuti arifu, inofanirwa kunge ichi benefita 7 electrons to the outermost shell. Kana kuti yobva yarasikirwa ne 1 electron kuti ive stable. Kuva stable kureva kuti yava nema complete shells. Pa first tati panoita 2, pa second panoita 8, pa third panoita 8. Saka ku sodium kune 1, kunoda 7 electrons, so that sodium will be what? Stable. Saka inoita say sodium will donate 1 electron so that it will be what? Stable. Yasara ne 2 akakwana ne 8 akakwana, yava stable, yava nema complete shells. And for chlorine to be stable, iri kungoda 1 electron. For chlorine to be stable, iri kungoda 1 electron. That's why tatora this one, this electron. Ndokubva taisa ku chlorine. So that chlorine nova stable. Chlorine yava ne 8 here. Sodium yava stable. Yava ne first shell rakakwana, ne second shell rakakwana. Chlorine yava ne first shell rakakwana, second shell rakakwana, and also third shell rakaita sei rakakwana. So ta achieve inonzi noble gas configuration. Right. Chichazoitika pama sign ma plus nema negative. Ndo panenzana ni cations and anions. Right. Sodium is a metal. This plus, it means 1. Plus, it means 1 in chemistry. Plus, it means 1. Plus, it means 1. Plus, it means 1. So, for sodium to achieve stability, you lost 1 electron. That's why it is a plus here. And for chlorine to achieve stability, you gain 1. That's why it is a negative. Because negative equals that E in any metal. Positive equals that E in metal. Do you know the ionic bonding? This is ionic bonding. So this one, chlorine, with a higher electronegativity, will attract 1 electron to sodium. And because sodium has lower electronegativity, it will donate 1 electron to chlorine with a higher electronegativity. Kutonzerano. Kutane power ndi anotora sina. Right. Saka ndo inonzi ionic bonding. This is ionic bonding. This is ionic bonding. Right. See now. Urikuona here kuti this one ya receive iyi ndokubva ya donate. Ndo saka tati chiti ionic bonding is when an atom either donate, for example, sodium donate only, sodium only donated, or receive, chlorine only receive. Chlorine never donate, but only receive. Right. That is ionic bonding. Yeah. I think you are getting it. You are getting it. You are getting it. You are getting it. Wow. Right. This is also a good example of ionic bonding. We have magnesium here. We have magnesium. This is metal, and oxygen, non-metal. Saka oxygen to achieve stability iringoda 2 my electrons kuno. That's why ya donaterwa 2. And why kuti ive stable iri kufana kurasikirwa ne 2 ndobva ta donata 2 acho 1 ndobva ta donata. Saka uchaona kuti iyi yava stable. Iyi oxygen pakatoita error yaifana kuita negative because this is a non-metal. Oh my god, yaifana kuita negative here. Yaifana negative. This must be a negative because this is a non-metal. It's an ion, so it is negative. It has a negative charge. When it receives electrons, it becomes negatively charged. And this one, when it donates electrons, it becomes what? Positive. That's why it had 2 plus, which means you lost 2 my electrons to be stable. It can gain now 2 my electrons to be stable. So it seems like always metals are the one that is going to donate to non-what? To non-metals. I think you are getting it. Wow. All right, let's go to covalent bonding. Covalent bonding is when atoms share electrons. In simple terms, covalent bonding is when atoms what? Share electrons. Is when atoms share electrons. And covalent bonding, it occurs between non-metals only. Between non-metals only. What is covalent bonding? Wow. Is when atoms share electrons. This atom will give 2 electrons, and another atom that receives 2 will also give 2. Saka ndipe ndikupe, yokanipa $2, indokupa 2. Hapana kuti apamwe 2 anozopuwa 8. No. Kungo share. Atoms, they are sharing electrons. Atoms, they are sharing electrons. That is covalent bonding. That is what? Covalent bonding. Okay, so what is the difference between ionic bonding and covalent bonding? Ionic bonding is when an atom either donates or receives electrons. But covalent bonding is when atoms share electrons between them. Right? Ionic bonding occurs between metals and non-metals, but covalent bonding occurs between only non-metals. Right? Let us look at this example of covalent bonding. And all compounds of covalent bond, they are called molecule. So this is water molecule. That's why you see this one is called water molecule. It's called water molecule. They are called molecules. That's why you see this one is called water molecule. Right? I think you are still following. All right. The formula for water is what? The formula for water is H2O, which means there are 2 atoms of hydrogen joined together with 1 atom of oxygen to give us what? Water. That's why there's 2 atoms of hydrogen here. So the electron configuration here, hydrogen here, there is H here and 1 electron. H and 1 electron. Saka trikuti 1 electron inodonetwa. Saka I'm going to draw this one so that you get it, because here wakangotangira mzira, but I'm going to interpret it. Right. We have hydrogen here. We have hydrogen here. These are 2 atoms of what? Hydrogen. And we have 1 atom of what? Of oxygen. Oh yeah. First shell and second shell. Then dots. These are called dot and cross diagrams. Even in Ionic, we use what you call dot and cross diagrams. Alright. See. Keep on watching. Keep on watching. Keep on watching. Right. Here we are. Alright. This is 1 electron. Hydrogen is 1 electron. 1 electron. Right. We are saying for oxygen to achieve stability, for it to be stable, for it to have complete shells, in other words, it must gain 2 electrons. So we are going to donate 1 here. Then oxygen we have now 7. Then we are going to also donate another one. And oxygen we have what? 8. Oxygen has now oxygen becomes now stable. Yes, becomes now stable. Right. But because this is covalent bonding, oxygen also must also donate electrons to hydrogen. Because hydrogen, it would have 1 electron for it to be stable. Sakatakutora 1 electron, 20 so. Uchiona the first shell hydrogen, rera bo yavane 1. Total of another one, yenda. Pa hydrogen inenge yao bo yava stable yavane 2. Because first shell tatino zarane 2. Ndo zvaitika. But atiri kushare acho tinomaisa pakati apo. Ndo zvangoitika chete. obva anopindana, so you draw like uri kuita masets ekumetsa, just like that. Ndozvangoitika. So this is covalent bonding. This is bonding for water. This one. This is bonding for what? For water. Hydrogen donated 1 and receive 1. Another hydrogen atom donated 1 and receiving what? 1. That is covalent what? Bonding, where atoms share electrons. Wow. Then this one again, this is oxygen. This oxygen, as you can see, this one, I want you to see this one, donated 2 electrons, this one, to this oxygen atom donated 2 electrons to this one, and this oxygen atom donated this axis electrons to this one, and they both become stable. That is covalent what? Bonding. So this is covalent bonding for oxygen molecule. I think you're getting it. Getting it. And also oxygen, this hydrogen carbon donated this electron to this one, and this one donated this electron to this one, and they all become stable. They have now complete what? Shells. All right, what are the properties or what you call characteristics of covalent and ionic bonding or ionic compounds? All right, covalent bonds, they are usually gases and liquids, does not conduct electricity in any state, low melting point, less than 200 degrees Celsius, then insoluble in water, and also then ionic bonding or ionic compounds is opposite a covalent. This is the opposite of covalent. Ionic compounds, they conduct electricity. 1, they conduct electricity, high melting point, soluble in water. I am insoluble in water. Then this one is low melting point, and this one does not conduct electricity. This one has liquids and gases. In this one, there is a point here. They are solids at room temperature. There are solids here. There are solids at room temperature. They are solids at room temperature. Well, for today we're going to end our next lesson. We're going to talk about what you call stoichiometry and the more concept. Please, if you don't share this video, I'm not going to upload the second one. So I want to see subscribers increasing, the number of subscribers, the number of views increasing. So after watching this one, just share to your friends. Just share, like, comment. We appreciate your comments, please. We appreciate your comments. Right, if you comment, you correct us, you give us some ideas. Your ideas are welcome. And we've now come to the end of today's lesson. So, wish you good luck, guys. When you are listening to this video, I know you are going to get it. I know you are going to understand. And I think these things will come to the examination and you are going to pass. So don't forget to like. If you don't like, just like, so that when I upload part 2, you'll get a notification message. You get a notification message. So for those who want online lessons, please contact us on this one: 078 62 82 464. This is my WhatsApp number. If you want online lesson where we are going to do question papers, we are going to revise questions so that you get your A, you can call me on this number. Goodbye.